morning, students. Welcome to physics class. Today we are going to study about that. So magnetic force, that is F, on a medium, a straight conductor carrying a water current, which is kept in a medium, the magnetic field. This particular magnetic field is a uniform magnetic field. So a conductor is placed in a uniform magnetic field, and then how much of a force which is acting on it. So let us consider, here is a conductor. This is the conductor of length L. Consider a conductor of length and placed in a uniform magnetic field. Uniform magnetic field, that is B. Uniform magnetic field, which is carrying a current. I is the current. So here the Lorentz force is given by Lorentz force is given by F of m. Let us consider the magnetic force. How much of a force which is acting? So that is nothing but the minus of E into V into B. E is considered as a number of the electrons, and V is the velocity. B is considered as the magnetic field on it. So therefore, what is the meaning of this N? N is considered as the number of the electrons which is present over there. So therefore, we can consider N is the number of electrons, and A is considered as A is the area of cross section. Area of cross section. A is the area of cross section, and N is considered as the number of electrons what is present over here. Now, how many number of electrons which is present over here? Let us consider a small length that is termed as a dl. A dl is considered as a small element of length dl. Small element of length dl. In this area, in this particular length, okay, so how many number of electrons which is present? So how to calculate that particular thing? Okay, so we already know that the number of electrons in the small element, the number of electrons in that element is nothing but N into, what is that? Volume of that. Okay, so total volume. Therefore, the number of elements is equal to N into A into, what I can able to say? dl. A is nothing but the area of cross section. We had already said that. So area of cross section into what is that? dl is completely length. N into A into what is that? dl. So therefore the magnetic force, or we can call it as a magnetic Lorentz force, in a what here, the small element, okay, the magnetic Lorentz force is given by, in a small element is given by F of m. I just mentioned as F of m. Here is a small letter Fm. Okay. Just I mentioned is the magnetic force in this particular element. Okay. D of Fm is equal to. Okay. So what I should mention? That is equal to what here? N A into dl and A into dl into what is that? Small fm. So the total area is present over here. So this particular element. So we already know the fm. What is the fm here? Minus of E into V into B. Let us substitute for this. That is equal to N A dl into what is that? Minus E into what is that? V into B. Therefore now let us simplify this one. What you will get? Minus of N A E into dl into what is this? V into B. Therefore, what is this? NAE into dl. Okay. We already know that this is nothing but a what here? I. I is nothing but a what? The current. And or otherwise, let us say, what is V here? The V is nothing but the drift velocity. The drift velocity is always given by what is that? dl divided by dt. dl divided by dt is nothing but a what here? Drift, the velocity. And we have NAE into dl. NAE into dl is nothing but a what here? dq. Okay. Here we have to put it as what here? Minus. Because it is in opposite direction. Therefore, substitute this thing to here. What do we get? D of Fm is equal to minus of, what you will say? dq into what is that? Minus of dl by dt into what is that? B. Okay. Therefore, d of Fm is equal to minus to minus becomes plus. So therefore, dq by dt into what is that? dl into what is that? B. What is dq by dt? The dq by dt you already know that. Okay. That is I. Okay. The rate of what is that? Flow of charge is called as an I. dl. Okay. dl into what is that? B. Integrate this one. Okay. d of Fm is equal to I is taken outside into dl into what is that? B. So what we will get? So on integrating this thing, so what we will get is f of m is equal to I integral of dl is nothing but l into. So this is the magnetic force when the conductor is a current carrying a conductor is placed in a uniform magnetic field. So therefore, F is equal to B into I into L. That is B. Okay. So thank you for watching the video. Thank you very much.